Okay, so today we're going to be doing problem solving involving compound interest. This is Year 12 General Mathematics, Unit 4, Topic 1.1.3. Where's my cursor gone? So our syllabus descriptors are, we're going to solve problems involving compound interest loans or investments. So by the end of today's lesson, you should be able to determine the future value of a loan, determine the number of compounding periods for an investment to reach a certain value, determine the interest rate needed for that investment to exceed a given value. So we're looking at compounding periods, interest rate, and future value. Should be able to also work backwards to work out the present value. So let's recall from Unit 1 and 2 the compound interest formula. Also mentioned it when we were talking about using a recurrence relation to model compound interest. So here we have it here. So the amount equals principal multiplied by 1 plus I to the power of n, where A is the future value, P is the present value or principal of the investment, I is our rate in as expressed as a decimal, and remember our rate is determined by the number of compounding periods there are per year, and n is the number of compounding periods there is. We also need to remember that if we need to find the interest, that we need to subtract the principal from that future value that we've calculated. So just like any formula, it can be rearranged to find different things. So first we're going to find the principal by rearranging the compound interest formula. So here's our formula. So if I want to find P, I've got to divide both sides by 1 plus I to the n. And there it is. So to find P, it's A over 1 plus I to the power of n. It's a bit more complicated when we've got to find I because it's within the brackets and has a power to it. So we write down our formula. First thing we need to do is divide both sides by P to remove the P from this side. So we get A over P equals 1 to the power of n. Now if I want to get rid of this n, I can multiply by its reciprocal, which is 1 over n. So here I'm multiplying both sides by the reciprocal to get rid of this. So 1/3 times 3 is 1, half times 2 is 1. So anytime you multiply by the reciprocal, you get rid of the n on this side. So A times P to the 1 over n equals 1 plus I. So now you can see that if I take away the 1 from this side, I can get I by itself. So the interest rate is the future value divided by the present value to the power of 1 over n, where n is the number of compounding periods, take 1. So let's work out how to use the compound interest formula to work out the future value. So the future value of compound interest loan or investment is the balance of that loan or investment after a number of compounding periods. So, for example, $4,500 is invested for 3 years at 6% per annum, compounded monthly. Use the compound interest formula to determine the future value of the investment. Write your answer to the nearest cent. So, our rate of interest is 6%, converted to a decimal is 0.06, but it's compounding monthly, so our percentage rate per compounding period is 0.05. So I divide it by 12. Our number of compounding periods, because it's 3 years, 3 times 12, 12 months in a year, is 36 compounding periods. And there's our present value. So we write down our formula. We substitute into the formula. So here's my principal. Here's my rate of interest. Here's my n. And so I get $5,385.06. So the the future value of this investment in 3 years' time will be $5,385.06. So working backwards to work out the present value. Right, so the present value of a compound interest loan or investment is the principal of that loan or investment. So use the compound interest formula to find the present value required to yield a future value of $6,842.85 after compounding every 6 months at the rate of 8% per annum for 4 years. Write your answer to the correct nearest dollar. So 8% compounding 6 monthly is 0.04. Our future value is $6,842.85. We've got 8 compounding periods, so 4 years, half yearly is 8 compounding periods. So we write down our formula. We rearrange the formula to make P the subject of the equation, substitute in, and to the nearest dollar, it's $5,000. And I'll just move that back up so that I can go to the next slide. So calculate the interest rate required. So this is a more complicated rearrangement of the formula, and you can go back to the slides before to work it out again. So calculate the interest rate per annum required that would allow an investment of $4,000 to grow to $4,200 over 3 years, where the interest is compounded every 6 months. Give your answer to 2 decimal places. So our present value or principal is $4,000. Our future value is $4,200. Our number of compounding periods is 3 times 2 is 6. And we need to find out what the interest rate is. So we write down our compound interest formula. We rearrange it to make I the subject. Substitute in to the formula. So when you work that out, it's 0.08165 per period, but there are 2 periods a year. So we need to multiply it by 2, and then we multiply it by 100 to turn it into a percentage. So that will be 1.63%. So they will need an interest rate of 1.63% to calculate that. Number of compounding periods. Now, this requires the use of trial and error to actually work out the number of compounding periods. So calculate the length of time required for $3,000 to grow to $4,000 at 5% per annum compounded quarterly. So here's our present value or our principal of $3,000. Here's our future value of $4,000. Here's our interest rate as expressed as a decimal, 0.05, divided by 4 because it's quarterly. So this is our interest rate per compounding period. And we have to work out what n is. So substitute in to my formula. So if I divide both sides by 3,000, I get 4,000 over 3,000 equals 1.0125 to the power of n, and n's what I have to find. So this is going to be 1.333 recurring when I simplify that. So now I have to find what value of n will give me 1.33. So I'm going to start with 5. So 1.0125 to the power of 5 does not equal 1.33. Let's try 10. 1.0125 to the power of 10 does not give me 1.33. Try 20. 1.0125 to the power of 20, once again, does not give me 1 1/3. 23, so 1.0125 to the power of 23 does give me 1.33. So I can, using trial and error, I can see that it would take 24 periods because I'm not quite at 3, right, where a period is 3 months. Therefore, it will take 72 months or 6 years to go from 3,000 to 4,000. So now it's time for you guys to do some individual practice. So I want you to answer the questions on page 255 and 259 of your textbook. When you've completed that, I want you to go to Study On, our online testing program. Once again, remember, make sure you end any previous sessions first. You need to copy down the summary into your summary book and then click on the page with the plus sign to answer the questions. Now, I want you to do that and pause the video. When you've finished, you can come back, start it here, and go through the answers to the 5 questions that are given on Concept 3 on Study On. So pause the video now. Okay, so I'm assuming because you're watching, you finished all those questions and you're either unsure of what to do in the practice questions or you have completed them and want to see the worked answers. So question 1, Airlie is looking to invest $12,000 for 2 years as she saves for a home loan. So 2 banks offer her interest rates of 6% per annum. One bank, it's compounded annually. The other bank is compounded monthly. How much extra interest will Airlie receive if she chooses Bank B's offer? So we're looking at one compounding annually, one compounding monthly, and the question asks us about interest. So let's look at Bank A. Interest rate is 6%, 2 compounding periods. Because it's annual, I don't have to divide my percentage by any number so it's just 1. Substitute into the formula and I get $13,483.20. So to work out the interest, we subtract the principal from the future value. And so in that period of time, she's earned $1,483.20. So what about Bank B? So once again, it's 6%, but now it's compounded monthly. So the interest rate per compounding period is 0.005. There are 24 interest periods because it's 2 years. So 2 times 12 is 24. The present value or principal is the same. Write down our formula, substitute into our formula. We get $13,525.92. Work out our interest. And so, but the question asked how much extra interest did she get? So the extra interest is when I take these 2 values away from each other and I get $42.72. Question 2. Bank A is offering an investment with an annual interest rate of 3.6% compounded per year for 4 years. Annie is going to invest $3,500. How much interest has she earned after 4 years? So here's our 3.6% expressed as a decimal. Right. It's compounding yearly, so we don't have to work out per compounding period. Write down our formula. Oops. Substitute in for our formula. Work out the answer. So $4,031.88. But the question says how much interest has she earned, not what the future value was. So you have to work out how much interest she's earned, which is $531.88, or answer C. Make sure when you're doing these questions that you actually look to see what the question is asking at the end. A lot of people would have got this answer here and would have pressed A. Question 3. So a bank is offering an investment of 4.2% annual interest but compounded half yearly. If Robert wants to invest $5,000 for 3.5 years, what would the investment future value be? So 4.2% compounded half yearly, 0.021 per compounding period. There are 7 compounding periods, 3.5 times 2 is 7. The amount he wants to invest is $5,000. Write down our formula, substitute into our formula, work out the future value. So the future value of this loan, or of this investment, is $5,782.96, which is answer B. Question 4. An investment house offers a term deposit with 5% annual compound interest. Janice invests $15,000 for 5 years. How much interest did she earn in the last year, the 5th year? So to do this, we need to work out how much interest she earned in the 4th year and how much interest she earned in the 5th year after 5 years and take them away. So at 4 years, we write down our formula. So 5% compound interest, 4 years, 15,000. So $18,232.59 will be the value of her investment at the end of 4 years. At the end of 5 years, the value of her investment will be $19,000. How much extra interest will she have earned? So if I take this one from here, I will get the difference in the interest, which is $911.63, which is answer D. So question 5, determine the annual interest rate to 3 decimal places that would allow an investment of $15,000 to grow to $18,000 over 3 years if the investments are compounded quarterly. So if you remember from the slides earlier, we'll need to rearrange the compound interest formula to make I the subject of the equation. So let's write down what we know. So it's going for 3 years, compounded quarterly, so that's 12 compound periods, growing from a present value of 15,000 to a future value of 18,000. So I've rearranged the compound interest formula to make I the subject. Substitute in. So if I simplify this, the thousands cancel out. So multiply by 100 to change it to percentage, multiply by 4 to get it into quarters. My interest rate is 6.12%, and we can see here that that will be answer C. Now, final question. The Dominion Bank offers an investment of 3% compound interest per year for any number of years. Fred wishes to invest for 5 years, and he would like to know what the equivalent annual simple interest rate is for this investment. The simple interest rate is, it says hint, make an imaginary investment of $1,000. So we're going to make P 1,000. So I is 0.03 because 3% converted into a decimal. 5 compounding periods because it's 5 years. $1,000. Substitute in, work out our interest. So our interest is $159.27. So we have to work out what simple interest will give us this as our I. So if we remember our simple interest formula, where I equals PIN, so if I rearrange this to make I the subject of the equation, I've got my interest divided by P times my number of compounding periods. So $159.27 divided by 1,000 times 5 gives me 0.03185. Multiply it by 100 to turn it into a percentage, and I get 3.185%. So this is the simple interest rate that is required to earn the same amount of compound interest, and so that will be answer A.